All right, let's get into it. Today, we are opening up the programmer's toolbox to peek at two tools that are, and I mean this literally, running our entire digital world from behind the scenes. We're talking about heaps and hash tables. They are the absolute unsung heroes of efficiency, and we're going to see exactly how they work.
I mean, just stop and think about it for a second. Your computer, your phone, it's juggling hundreds, maybe thousands of tasks at once. It's sifting through massive amounts of data. So how in the world does it know what's most important? And how does a database find that one specific photo you're looking for out of thousands in like a fraction of a second? Well, it's not magic, I promise you. It is just some seriously clever engineering.
And that engineering, that cleverness, it all comes down to how we organize information. In the programming world, we call these organizational methods data structures. And really, they're the difference between a desk buried under a messy pile of papers versus a perfectly organized filing cabinet. It is all about taming the chaos. It's all about data, speed, and order.
Okay, so first up in our toolbox is the heap. You know, the best way to think about a heap is as the ultimate to-do list. Or maybe even better, think of it like an emergency room triage nurse. It has one job and one job only, to always know what is the most important, most critical thing that needs attention right now. So, to get a little more formal, a heap is the most efficient way to build something we call a priority queue. And it's exactly what it sounds like. It's a queue that doesn't care who got in line first, it only cares about who has the highest priority. A heap structure makes sure that the most critical item is always right there at the top, ready to go. No searching, no sorting through the whole list, it's just there.
And believe me, this isn't just some abstract theory. Heaps are absolutely everywhere. Your computer's operating system uses them to decide which program gets the CPU's attention next. They are the beating heart of algorithms that find the shortest route on a map, like Dijkstra's algorithm that your GPS uses. They are a fundamental, critical piece of modern computing.
So this is its superpower. A heap gives you immediate, instant access to the extreme value, either the most important or the least important item. It does this in what we call constant time, which is just a fancy way of saying it's instantaneous. It doesn't matter if there are 10 items or 10 million, but, and this is a really key distinction, it's only for that single top priority item. It's not built to go find some other random thing in the middle of the list.
And you know, for all you performance junkies out there, it gets even better. The standard binary heap, that's the workhorse you see on the left. But there are even more specialized versions, like the Fibonacci heap on the right. These are engineered to make certain things like adding new items even faster on average. It just goes to show how deeply optimized these structures can get.
Okay, so heaps are the undisputed champions of priority. But what if you don't care about what's most important? What if you just need to find one specific thing, and you need it like yesterday? Well, for that, we pull a different tool out of the box, the hash table. This is the ultimate index. Think of a hash table like a coat check at a fancy restaurant. You hand over your coat, that's the value, and you get back a unique little ticket, that's the key. Now, when you want your coat back, you don't have to search through all the coats on the rack, right? No way. You just hand over your ticket and they go directly to your coat. That's exactly what a hash table does. It maps a key to a value for incredibly fast retrieval.
And the secret sauce that makes this all work is something called the hash function. Let's just follow the steps here. First, you give it a key, like the word apple. Second, the hash function runs that key through some kind of mathematical process. And finally, it spits out a number, which is a direct address, an index. It's like a perfect address generator. For this particular hash function, the key apple will always lead you straight to spot number 4.
This direct mapping is why hash tables are ridiculously fast. On average, the time it takes to find, add, or remove something is what we call constant time, or O of 1. This, my friends, is the holy grail of speed in computer science. It means it doesn't matter if your table has 10 items or 10 billion items, finding what you're looking for takes the exact same tiny amount of time. It's pretty much instant.
Now you're probably thinking, okay, but what if two different keys, like apple and orange, get run through the function and both end up pointing to spot number 4? That's a fantastic question. It's called a collision, and it definitely happens. But don't worry, programmers have come up with really clever solutions for this, like creating a little mini list at that spot or just looking for the next open slot. It's a totally solved problem.
So we've got two incredibly powerful tools. The heap, a master of priority, the hash table, a master of speed. So, how do you know which one to use? Well, it all comes down to picking the right tool for the job.
When you see them side by side like this, the difference becomes crystal clear. You use a heap when the question you're asking is, what is the absolute most important thing I need to deal with right now? You use a hash table when your question is, where's the file named quarterly_report.docx? One is for order and priority, the other is for direct, lightning-fast lookup.
And if you look at the performance numbers, they tell the exact same story. Check out that hash table column, O of 1, constant time for pretty much everything. That is just raw, unadulterated speed. Now look at the heap. Inserts and deletes are a tiny bit slower at O of log n. But look at that last row. It gives you that priceless O of 1 access to the top priority item, the one thing a hash table just can't do.
So, let's wrap this up. As we zoom out for the big picture, what's the one key takeaway you should really remember about these two amazing tools?
Honestly, it all boils down to this one simple, powerful trade-off. If your program's life depends on always knowing what's most or least important, you need a heap. If its life depends on finding specific things as fast as is physically possible, you need a hash table. That's the choice. Priority versus speed.
And why does any of this matter to you? Because every single time you search for a contact in your phone, use a GPS, play a game, or just let your computer run, these silent, efficient engines are working their magic in the background. They are the perfect example of the kind of elegant solutions that make our incredibly complex digital lives feel so simple.
Understanding these things helps us appreciate the sheer brilliance hiding just beneath the surface of the technology we use every single day, which, of course, leaves us with one final thought. Now that you know about these two, what other invisible engines are out there, quietly and efficiently powering your digital world?